Hello, this is checkpoint 2.16. In this checkpoint, they want us to look at the set of points that satisfy this particular equation. Let's see if we can rewrite this equation. This is going to be y plus 2 and z minus 3, and this is equal to 0. Now, if we just simply solve for this equation like we remember how to do, we would, these are factors set equal to 0, so we would set each factor equal to 0. That's z minus 3. So y plus 2 equal to 0 gives us y equals negative 2. And z minus 3 equals 0 tells us that z is equal to positive 3. If we take a look at these as a way to describe equations, or as a way to describe a set of points in 3 dimensions, we can imagine that when y is equal to 2 as our only restriction, that tells us that it doesn't really matter what x and z are equal to. So if we focus on y is equal to 2, and we imagine, let's draw our three-dimensional space, x, y, and z. And then we say y is equal to negative 2. Y is equal to negative 2 would bring us somewhere over here along the negative y-axis. Let's label that as negative 2. And what that's telling us is that y is negative 2, and it doesn't matter what x and z are equal to. So I think this will eventually become a plane that has the y value of 2, and x and z can be anything. So this describes a plane passing through y is equal to negative 2. Okay, so I want to say a little bit more. This is parallel to the xz plane. All right. That's one of the planes. Well, that's one part of the graph, and now they want us to describe this graph, and this graph is z is equal to 3. Now we can climb up the z-axis and get z is equal to 3 here. And now we have a point z is equal to 3, and what they're saying here is that it doesn't really matter what the x and y axes or what the x and y values are, z is always going to be equal to 3. So again, that's going to describe a plane, and the plane that it'll describe is going to be kind of tricky to draw this, but it'll be a plane that is parallel to the xy plane, passing through z is equal to 3, and then parallel to the xy plane. Okay. So these two planes are drawn here. We can get interesting here and say that they actually intersect at a line, and that's piece of information that we'll take later on, and we'll do something more about that. But for now, when we're describing this equation here, we're talking about two planes, and one plane that's y is equal to -2 parallel to the xz plane, and then another plane z is equal to 3 that's parallel to the xy plane. All right, I hope that helps.